All right, good morning, good afternoon, everyone. Thank you for joining us today from wherever you are. My name is Adam, Content Marketing Specialist with Henry Schein, and I will be your moderator. I'm pleased to be joined by Professor Gianluca Gambarini as our speaker today. If you have questions for Professor Gambarini at any point during today's webinar, please type them into the Q&A section, and we will answer them live at the end of the presentation. This webinar is presented by Henry Schein, and no CE credits are being offered for viewing or attending today's webinar. With that, I'd like to thank Professor Gambarini for being with us today, and take it away.
Okay, good morning and good afternoon and good evening for all the attendance from many countries in the world. It's my pleasure to be here today speaking about new endodontics techniques and new instruments. And we have been done many studies about this, and most of them are published in the peer-reviewed endodontic journal. But the main idea here is that we have endodontics image given by X-ray that only show the clinical view, which is a partial view. It's not the real view. There's also another view, which is the hidden view, which may look totally different. So, for example, these two canals may look very, very similar from a traditional radiograph, from the clinical view. But if we see from the hidden view, the CBCT view, we understand clearly that they are totally different, and the challenges that we are facing are totally different. And so in the first case, we have banana curve, which are very easy to manage with the current NiTi rotary files. And then we have elbow, abrupt curvature that still can represent a danger. And when we just use our instrument inside, most of the time we don't really understand what kind of curvature, which kind of complexity we are facing. So what I'm saying here is that what has changed a lot in the recent year is the understanding of the anatomy and obviously the consequence of the anatomy on our instrumentation. And so there are not only two-dimensional curvatures, but there's also a lot of hidden dangerous anatomy that may ask for more resistant instrument. Another example, for example, of MB1 and MB2, in this case, MB1 and MB2 may not look so complex in two-dimensional. And actually, we may say there's no big difference between the two of them. But if we follow the path and the trajectories in three-dimensional, we may very easily see how more difficult is MB1, the green, and way, way more difficult the MB2. If not sometimes nearly impossible. So by knowing this, we have to know that improving our knowledge made us understanding that the canals are more curved and more complex in 3D. That's why we now require more flexibility from our instrument. The three-dimensional anatomy is more stressful for the instrument. That's why we currently need more resistant instrument. And the canal shape is not round in 3 dimensions, so we need instruments that are very efficient in terms of cutting and removing debris. I'm showing an example here about a case I was asked to treat a perforation, but actually the other tooth has a lesion. And the root canal therapy on 2.1 looked quite good, but there was a lesion after 3 years, so there was not a successful treatment. Now, if we go and have a look at the cone beam, and if we go from coronal to apical, we may see that when we go down in the middle and apical part, we see some areas which are not filled. So it may be a defect of the obturation, but it could be that there's a lot of debris left inside the canal that did not allow obturation to three-dimensionally fill the canal. So no surprise that we have a lesion very clearly, even if the apical obturation is very nice. And if we see the same case from another view, we may really see the lesion, the part that was not properly clean, shaped, and obturated. So this is the other incisor with the perforation. So in this case, we retreated the case only by improving instrumentation and improving cleaning. And that's why we were able to make a much better treatment. And for the other case, which was a little bit more complicated, we had to refine again the original path and then also repair the perforation that we managed. And this kind of situation we call mistreatment, meaning that a part of the root canal therapy inside a canal was not properly performed. And we have a lot of cases also because we don't see this kind of small lesion sometimes in two-dimensional radiograph. So everything looks fine, but actually, if we make a 3D image, it's not the case. And we can show quite a lot of cases like this, especially in oval canals, which are obviously more challenging than the round ones. So the basic idea about this is that if we think in a very simple way, our endodontic therapy is like cleaning a table. So to clean a table, we don't need to cut a lot its surface, but we have to touch all table surface using some chemical and some force to remove the debris and the dirt attached. So by saying this, it means that we have to transfer our knowledge, our understanding of the anatomy into performance, into efficiency, into safety. So when I have to think about the ideal properties of the nickel titanium rotary instrument, there are three main properties I want to address. The first one is the flexibility to go inside complex canal and to negotiate complex curvature with no iatrogenic errors. The second one is resistant to fracture. We may have an instrument very flexible, but we also need this instrument to be resistant. We don't want our instrument to go inside very complex curvature and break inside the curvature. And the third one, last but not least, we need efficiency in terms of cutting and debris removal. So this is very clear. And so the idea was to design and have an instrument that follows this principle in terms of cutting efficiency, in terms of resistance, in terms of flexibilities. And this is the Edge file X7. It's a heat-treated NiTi file. It has a lot of quite interesting features like the parabolic cross-section, the maximum fluid diameter 1 millimeter that reduce a lot the risk of screwing in and taper lock, the constant taper, and also we have a small endo, and we have the availability of this instrument in sterile pack. Now, why a new file system? Well, what I will try to explain today is what is my philosophy and what is my idea and why a new file system actually fits this kind of requirements. So my belief is that we need increased performance and safety from our NiTi rotary instrument, but we also have to increase simplicity. So we can use quite a lot of instrument, but what I'm proposing today is a very simple, very user-friendly technique by using only 2 NiTi rotary files. I also think versatility is very, very important because sometimes, depending on the case, because the anatomy is so variable, you may play a little bit with some options, including tapers, including motions, and I will show some of these possibilities. And last but not least, I want to be, in a certain way, following the trend of minimally invasive endodontic treatment, but in a slightly different way, because sometimes we can be minimally invasive, sometimes we cannot. So my idea is to make a technique which is racially invasive, and I will try to explain you why is racially invasive and not minimally invasive. So we have to start this travel and concerning about NiTi rotary instrumentation. And first of all, we have to know the properties of our instrument. And we have to know that the properties of our instrument are influenced by three main factors: design, manufacturing, including heat treatment, and clinical use emotion. Obviously, the design is very, very important because it affects the manner in which the instrument engage in cut denting, remove debris, and the stress that they may generate with them. But what has become more important in the last decade actually is the manufacturing process and the heat treatment. And heat treatment before, during, or after the manufacturing of the NiTi rotary instrument have been proposed to improve the mechanical properties of the alloy, flexibility, and fracture resistance. And in the last years, this has become probably the key factor in designing a new instrument. Because with the design, you can play and you can make some improvement, but the improvement will be small or significant, but not extremely significant. But when you have a very, very good heat treatment, you may really increase a lot the performance of the instrument way more significantly. So we have to know that the grinding process weakens the NiTi files both externally and internally, because it produces heat, it produces mechanical stress, and this mechanical stress will result in some external defects, surface defect, and we can manage them a little bit with electropolishing, but also, as we are showing here, it can create quite a lot of small hidden defect inside the structure. And this defect we can only try to mend by making a proper heat treatment. And so the heat treatment can repair defects by restoring the structure, the strength, and the sliding of the NiTi crystals. And to show you how things can really change by changing the heat treatment, I will show you a comparison that we made in a quite recent study on applied science. Actually, we had made a very nice device about testing flexibilities of the instrument. But I want to show a compare between Pro Taper and Edge Taper in their also in the gold and the platinum version. So if we check the instrument at the normal alloy, we may see, for example, that Pro Taper is slightly a little bit more flexible than the Edge Taper in both sizes. But when we heat treated this file, and this is the gold and the platinum, it's totally the opposite. We have a significant increase by the firewire heat treatment made by the EdgeEndo. So the S1 from Edge Taper Platinum becomes way more flexible than S1 by Pro Taper Gold. And the same happens for the F2. So practically speaking, one treatment increases a little bit less than 2 times, and the other heat treatment increased quite a lot. And we can see this. So now what we have on the market, we may have a traditional NiTi system, which are, for example, the Edge Taper. We may have slightly martensitic, more flexible heat-treated file, which are the Edge Taper Platinum, with a significant increase in instrument flexibility. And also we may have a more martensitic file, like the X7, which are way more flexible than the other. And they can be pre-bent quite nicely and easily. So we have 3 new categories of nickel titanium instrument. And also we have to learn how to use them and when to use them. And we have to know what's the difference between one and the other. So as I told you before, the firewire, the heat treatment, increased flexibility. But luckily, by doing this, because it's restoring the crystal, it is also increasing quite a lot the resistance of this instrument to cyclic fatigue, to bending stress. So we know that intracanal failure happens when instrumentation exceeds the resistance of the file. And mainly we have two kinds of stress. Bending stress, which is also called as cyclic fatigue, in which the stress are mainly located in the middle of the curvature, where we are showing, and torsional stress, when the stress is applied mainly in the apical part, and this stress can be often at the tip, but sometimes also also related to curvature. It's not easy to determine all of this because the two stresses happens simultaneously. But what I'm really want to tell you, what is very important to you to know, is that sometimes the instrument breaks at some point, but the stress is not placed in the same point where it breaks. Meaning that there are some hidden curvature that we don't see that may create a lot of stress to the instrument, and the instrument will break in a more delicate point, but not because of that stress, because the stress sum up. So having said this, when we have very complex apical curvature or multiple curvature, these are the typical situation we see on a radiograph, and we fear that our instrument will suffer from excessive stress. We have a very clear strategy to apply. First is to try to eliminate all the coronal interference to make life easy for our instrument. And this is a general principle that has been called crown down for many, many years, but I think that is still a very, very important thing to always keep in mind, that the more we eliminate the coronal interference, the better or the easiest we make the life for our instrument and their work. But also, in this kind of cases, when we have complex apical curvature, we may decide to use more flexible and resistant NiTi instrument. And the Martin Citix X7 actually works very, very nice in this kind of complex curvature. And obviously, we may have this instrument in different tapers, 04 and 06. But my suggestion is that when we have to deal with this kind of curvature, it is safer and it's better to use the small taper, 04. And then we will find some way to compensate if we need a little more enlargement. And the 4 suggestion I can give you is you can also use safer motions or safer techniques. You can play a little bit on the motion, on a clinical technique to make, once again, the life more easy and less stressful for your instrument. So if you follow all this kind of strategy, you will be able to very nicely perform root canal therapy also in complex cases. And this is also extremely important in the very, very complex cases where actually we may try to modify a little bit the curvature like this, but at the end we have to rely on the properties of the selected instrument. Another thing I want to tell you, which is sometimes a little bit forgotten, is that when we have confluent canals, or when we have two canals in one root that join together close to the apex, we have always to ask ourselves a question, and the question is, which canal first? Because if we see cases like this, what makes this case easy or difficult is not the anatomy, is not the instrument, it's the way you are approached to this canal. Because we know that when we have confluence, we have to prepare the easy canal to the apex, to the working length, and the more difficult only up to the confluence. So in this case, if we start to do the distal first, I mean, this is a very, very easy case. The medial, we stop at the point of the confluence and we do quite easily such a case. But if we do the opposite, if we start treating the medial and then we go inside a lot of complex abrupt curvature and the buccal one, we may skip the problem, but maybe in the, or maybe not skip the problem and have some iatrogenic errors or even breakage of the file. So we have to be very, very careful and not to do the medial first in this case. If you follow, all these rules and you use the right instrument, the flexible one, you will have this very, very nice image. This is a three-dimensional image of the case, and you'll be very, very happy about the performance of the instrument and the final result of your treatment. Some people also use prebendable Martin-Sitting instrument to make insertion easier and less affected by interference. So this is also happening for this kind of ninja axis, truss axis. Actually, we don't have time today to discuss all about this, but the fact when you have some interference, or for example, when you don't have space, vertical space, because the patient doesn't open the mouth enough, the fact that you can pre-bend your instrument like the X7, it's a big advantage because it's way easier to insert the instrument inside this complex situation. Speaking about strategy, and when you're using this instrument inside the root canal, the main rule is that you should never force a NiTi rotary files when it does not progress. Many people think that the file don't progress because there is a calcification. No. Since you have already scouted with a K file the canal and you already established a sort of glide path, when the instrument does not progress, is because there are hidden curves and maybe because of taper lock or the fact that you make some debris and some canal blockage. So you must stop, you have to increase flaring or improve glide path, or even if you want, you can recapitulate. What I'm telling here in this case is that sometimes there are hidden curve in the middle part that if you don't think and if you go there with a big taper instrument and thinking that it's a very easy part of the canal, you may have some surprise. So sometimes the fracture in the past was defined as a sudden, unexpected fracture of NiTi. Well, actually, if we look at the anatomy, in this case, for example, we may understand why it fractured and then try to mend this. So the prebendable Martin-Sitting file, especially the X7, are also extremely useful in divergent canal, and also they can also reduce the risk of taper lock because their maximum diameter, which is very small. So I think this is a quite interesting new generation of file that allows you to treat in a much more interesting and profitable way the complex anatomy. So once again, when you have a case like this, when the canal disappear, and it's not because we have a calcification, it's because actually there are two canals in one root, and we may see this from a 3D very easily, and this is the case like this. So also we may have some coronal interference, and the coronal interference may also affect the instrument because they put a lot of stress from the very beginning. So luckily with the X7, the instruments are a little bit less susceptible to this kind of bending stress because they are extremely flexible. But anyway, when we have this kind of interference, we have to increase the straight line effects. We have to eliminate the coronal interference, the dental interference, and we have to slightly modify our access cavity. We have to flare the coronal part of the canal, and obviously you have to use martensitic flexible file to make life easier in this kind of double curvature. Speaking about the resistance of the file, luckily we can measure. And also we can measure the difference we have between a heat-treated and non-heat-treated file. This is another recent study we published about the influence of different heat treatment on torsional and cyclic fatigue resistance of different nickel titanium instruments. So once again, we compare austenitic file, edge taper and pro taper, and heat-treated file. And if you see the resistance to cyclic fatigue, I mean, you may really understand that how can we significantly increase a lot the resistance of the files, for example, the edge taper platinum, only by making an innovative heat treatment. So this is why heat treatment now is a fundamental step in the manufacturing, and firewire treatment increase very, very high both the flexibility and the resistance for more safety and for increased performance. And if we think about Edge X7, because of it's more flexible and also because of the design and structure, is even more flexible and more resistant to fatigue rather than the edge taper platinum that was before sort of highest standard. So we still have interesting and very significant increase in the performance of the instrument. In terms of torsional resistance, there's not a big difference. Well, there is no improvement actually in the torsional resistance by heat treatment. In most of the cases, we may say that torsional resistance is less affected by the heat treatment. So what we have to do, we have to think about how can we reduce torsional stress on the file. Because, I mean, the heat treatment allows us to improve very easily flexibility and resistance to bending, what we can do now for the resistance to torsion. So this is an interesting study that we made, and you can also, if you want, you can take your camera or your phone and just, click and make a screenshot of this image so you can download the article about this. And this is a study about the torsional resistance of this kind of file, which is pretty good. But what I'm more interested is not the real resistance itself, but I'm more interested about the operative torque. Which is the operative torque? What does it mean? Well, the operative torque is the torque or the load that is needed by the instrument to reach the working length. And obviously, it depends also on the dimensions of the file, on the taper, on the working part of the file. So the smaller the dimension, the smaller the taper, the smalling is the length of the working part, the less is the operative torque. But very interesting here is that the operative torque actually is a measurement of the cutting efficiency. Because if it needs less torque, it means that there's easier progression that shows better cutting efficiency of the overall instrument. So if we make a comparison here between the X7 and ProTaper Next, here we can very easily show that the mean operative torque for the EdgeEndo X7 is much lower, meaning that it's a much more efficient file, but also it's less risky file because if we also consider the maximum of operative torque, the peak torque, which are the dangerous one, we see that they are nearly half than the other one. So you can see this in two graphs. To the left, we have the X7. To the right, we have the ProTaper. So we may have a much more delicate instrumentation, but also much less stressful instrumentation with X7. And we published this recently in 2019 on the European Journal of Dentistry. And I think this is quite interesting result. And if we make a sort of comparison between the operative torque and the torque of failure, so which is the torque needed to break a block filed, we know that ideally the first one, the operative torque, should be low and the second one should be high. And so we introduce a new concept, which is the torque range, which is a sort of safety range that we can have in our instrument. And if you look at this, so it's a comparison between the torque we need to progress and the torque that it's a riskful one. So the EdgeEndo works way better than the ProTaper Next with a much wider, efficient and safe range. And this also was published this year on the Saudi Endodontic Journal, and you can take a screenshot if you're interested. So having said this, we understood quite a lot. We are not able, in a certain way, by the heat treatment, to increase the torsional resistance, but by having a lower operative torque, we actually increase torsional resistance of the X7 because they will need much lower torque values to be used. So they have a wider safety range of utilization. Having said this, there is a third important point, which is the clinical use emotion. For many, many years, NiTi rotary instruments have been only used with continuous rotation. Nowadays, we have a lot of different options. We have a single motion, including reciprocation. And for many years, we only had reciprocation in a counterclockwise direction. Nowadays, we can have also reciprocation in clockwise direction. And we have to know that X7 and the H-Taper Platinum know this kind of file that I've been showing to you before are always cutting in a clockwise direction. And also we may have combined motors like OGP, OTR, TFA, which are a combination of continuous rotation with reciprocating motions. So there's a lot of new things, and also there are parameters of use that they may vary. So usually speaking, that's the manufacturer will give you the preset or suggesting setting about torque and speed. So mainly this kind of setting are around 2 newtons per centimeter. But actually, then the dentist may play a little bit and decide to use them with a low torque technique, so reducing the torque, or some people prefer to use them in a maximum torque with no control higher than 4 newtons. Well, the good news is that, this is also depends on your touch, on your approach to the canal. So actually the X7 will work nicely with any of these changes, because one changes increasing the torque will make them a little bit more efficient, and they already are efficient. And the green one, the low torque technique, they will make them a little bit more safer, but they are already safe instrument. So actually, I think that's it's probably more important as we will see the way you use the instrument, the clinical way of using the instrument, rather than the setting. And the same you can also do with the speed. And we can use a low speed, a medium speed, a high speed, a very high speed. And it also depends on the torque that you're using. Obviously, if you increase the speed, you may decide to reduce the torque. But this is, once again, it's a factor, but it's not a relevant factor. What is more important is that nowadays you have a lot of additional features in your motors. You have cordless motor, you have endodontic motors with integrated apex locator. This is one from Morita. And we tested quite a lot of this kind of motor, very successful. And also you have small head dimensions, and you also have new motions. And it's quite complicated now to go in all this motion, but my idea is that I like to use open motors in which I can slightly play and modify it, and I have some option. And I will, this part, also show you a little bit of my philosophy. So what I do, usually I have at least 4 speeds and 4 torque settings in my motors. And you see that you have this in 1, 2, 3, and 4. I have at least 2 reciprocation motion clockwise that I can use for my instrument. I have counterclockwise, I'm not using for this instrument. I have reverse that sometimes I use if, which is very rare, the instrument blocks inside the canal. And also there's other options, including other motion like OTR and combined motion that can be used as a substitute of one of each of them. So you have a lot of options. That makes your technique slightly more safe, slightly more efficient. But actually, for the X7, I can tell you can use any of this. We tested all of them, and they works very, very nice. What I'm trying to teach you today, actually, is the importance of this kind of motion, but also the importance of the sequence and the clinician handling of the instrument. So what is the clinician handling? What does it mean? It's the way you're using the instrument. For many, many years, NiTi instruments have been used in one way, only while you're getting in the canal. The idea was to reach the apex and then remove the instrument immediately. Well, the main problem here is that working into the canal, it's a reaming action that is the dangerous one, and you have to be very careful. And the suggestion that you have to go in step by step. But actually, you can also do quite a lot of enlargement, quite a lot of cleaning by using your instrument while getting out from the canal as if they were Hestrom. So I divide my techniques, and I wrote this an article in 2010, more than 10 years ago, about this idea of dividing instrumentation in 2 phases, while getting in, which is the dangerous part, and while getting out, which is a much safer part, and I can do a lot of work, a lot of job with no risk, and with a very high efficiency. So when you go in the canal, your NiTi rotary instrument is a reamer, and here you have to be very careful to avoid all the mistakes, all the zipping, the ledging, the blockage, the deformation, the fracture, like this. So be very gentle, very delicate, goes down in step. But once you get to the working length, you can start to get out, and you can play quite a lot of your instrument. You can try to touch all the canal walls. You can try to flare match the canal. You can do quite a lot of things. And the interesting thing here, and these are studies that we made with a special device that we were able to measure the stress while the instrument were working in vivo on patient, that working in is very stressful and it's very dangerous. Working out, it's very safe. We can brush, we can flare for even minutes. We can increase the speed. We can do a lot of things with no risk. So the idea is that working out of the canal is extremely efficient technique for cleaning. And in this case, we call the motion brushing or circumferential filing because we want to touch all the canal walls. But it's also a very interesting technique for shaping. And in this case, we call this brushing or selective flaring or flaring. And we can very easily show that in terms of cleaning, when we have an oval canal, a slightly oval or even an elongated canal, we have to move our instrument and try to touch all the canal walls. If we follow this philosophy, X7 are very nice because since they have a smaller taper and they have a smaller working part, they can much more easily reach all, and they're very flexible, all these irregularities in the canal, and without the risk of over-enlargement or modification of the canal. But there's a lot of advantage in terms of flaring. So the idea here is that when you work out, you can do a safer and prolonged enlargement. You can flare in a much nicer and efficient way. You can create more taper than nominal size. That's why if I'm using a 04 and I flare or I brush, I can make a 05 preparation or even 06. So I don't need to use a highly taper file. I can be minimally invasive. I can be conservative with the X704. And when I need more flaring, I can flare, but only when I need, not by definition, because I'm using a file with a greater taper. And obviously, if I do this, it helps quite a lot of reducing the number of files. So this is another example, and this was also published, that's we are making the same clinical situation with no brush with the previous file. We have more stress. If we already have brush and flare with the previous file, we have much less stress. So this is actually tells us that every instrument should be used with two phases. One phase is working in, and second phase is working out with some flaring. And this will also make the life easier for the next instrument. So we can skip the stress, we can skip the number of files, and we are following the crown down procedure. Speaking about this, some people say, okay, if you flare, you modify the canal. Well, actually, I want to explain to people the difference between canal transportation and canal modification. In canal transportation, this is a iatrogenic errors. And the canal modification you do when you go out from the canal, and so it's on purpose. So canal transportation occurs as a mistake while you're working in. Canal modification is a strategy, is a choice while you're working out. And in the canal transportation, the canal works over the files. So the canal, the curvature, makes the file not working in a proper way. And with the canal modification, the files win over the canals because the file modified the anatomy to make it, in a certain way, more easier for the treatment. So this can, from an engineering point of view, can very easily then be demonstrated that selective enlargement, the coronal flaring, reduce the angle and increase the radius of curvature, less stress, shorten the length of the curvature, less stress, eliminate and reduce coronal curvature, less stress. So what I'm telling you is that when you're using X7, the X7 helps you a lot, but also you have to, like any instrument, you also have to help your instrument to work in a better environment and try to do this kind of canal modification. And if you want to be a little bit more sophisticated, if you think in a three-dimensional way, you have to do selective flaring in two directions. For example, in a lower molar, not only major flaring, but also buccal flaring. And if you do like this, you have these very, very nice cases done only with two instruments very easily with virtually no or minimal risk. So the idea is that what's the difference between minimal invasive and rationally invasive is that I think that my flaring, my amount of enlargement is not dictated by, a decision at the very beginning or a philosophy, but it's dictated by the anatomy. So I only need to make curve easier by reducing interference. So the amount of three-dimensional coronal flaring depends on the apical complexities on the apical curve. So the more complex, obviously, the more flaring, the more straight line access is needed. This is why, in this case, we needed to flare in order to have, a proper straight line access in the coronal part and to manage that complex curvature. But in a case like this, when the curvatures are not so prominent and are quite easy, we don't need to enlarge the canal a lot. We only need to touch the canal walls. You have to remember the table that I was explaining before. And so this shows you a minimal invasive preparation. But in this case, I can be minimal invasive because we have a rational. And also, in this case, they look complex, but they are not, because we only have to understand where the confluences are located. And since the canal are quite straight, we don't need to enlarge too much. Obviously, what we cannot change are the apical curvature. We can modify the coronal curvature, we can modify the access cavity, we can slightly try to modify the middle curvature, but the apical curvature are very difficult. So in this case, we have to use more flexible file, more resistant file. So martensitic X7 file are perfect for these cases. And what we can do, actually, we can play a little bit with the motion. We can, if you want, you can use them manually. If you want, you can use them with a little bit safer continuous rotation. You can use them with a reciprocation or any other combined motion. But you have to know that this will be stressful. But what is more important here is that since you cannot modify the apical curvature, you only have to make this curvature easier by slightly modifying the coronal part of the canal and the SS cavity. So actually what I'm doing, I have a three-step anatomical approach in curved canal. The coronal part, which is theoretically easier, but can very easily produce stressful interference and can be complex when we have when it's curved from the very beginning, and we have to start our therapy by reducing this kind of interference or by improving coronal flaring, or when we have a poor SS cavity. The middle part, we have to be very careful because it's quite very common in major roots of molars to have hidden curvature, sometimes more coronally and apically than we could think. And this can sometimes be the responsible of the failure we see in the apical part of the canal. And apical part is usually more complex, but luckily the curvature are most of the time visible. And since the curvature can sum up and induce more stress, the strategy I want to suggest you is to reduce coronal stress, both bending and torsional stress, by straightening the curve in the coronal and ideally middle part and the large canal before progressing more apically, and to use more flexible and resistant and less invasive file, which is the X7, and to be rational invasive, only flare to make this kind of curvature easier. But there are also other things you can do. You can a little bit use also for getting in the canal. You have to use a technique which is a little bit more delicate, and it's also a little bit safer. And once again, this is a technique we proposed years ago with this article. It's called Mimerachi, and it's step-by-step technique. MI is called manual insertion, ME, minimal engagement, RA, remove the file from the canal, and CI, cleaning flutes and ideally irrigate canal. And it's a step technique, and you have to repeat all the steps till you get to the apex. And also you can brush if you want at any step to improve cleaning. So very easy manual insertion. You insert the file still till you feel resistant. Then if you want, you may also slightly retrieve a little bit. And then you progress only for 1 millimeter or 1 second of predictable advancement. If you do this with the Mimerachi, you will be much more predictable and much less stressful than any other technique, than any other packing motion or any other suggested technique. At this point, you have to take the instrument out from the canal and clean the flutes. Why? Because we proved that if you clean the flutes, you reduce the torsional stress. And once again, this is an important way to reduce the torsional stress. And also, you avoid over-engagement of the file, and you also avoid overproduction of debris. And at this point, you can repeat this you can brush, and you can repeat this sequence more times. We recently made a quite nice video about the X7, about Mimerachi technique, manual insertion, minimal engagement, removal of the file, and cleaning. And it shows quite nicely that, also in complex canals, this step-by-step minimal approach with some brushing in between the steps also helps quite a lot to address, the difficulties. Because when you go very slowly down, you don't overstress the instrument, you understand the curvature quite easily, and you can understand the progress of the file and understand the complexity that you're facing, that you may see, but you may not see on the radiograph in the three-dimensional because it's way more complex. So I think this is quite an interesting technique to adapt, and you can adapt to your instrumentation. And it has proved to be very, very, very nice. And once again, also for the Mimerachi, the amount of final brushing is related to the canal dimensions. And the brushing actually is what makes the final shape of our canals, but it's also related to the anatomy. Because sometimes the canals already have that kind of anatomy that we must respect. We only need to touch the canal walls. Having said this, we can use the X7. We have 04, 06. We have different sizes. And we can use a full sequence. You can use a simplified technique. You can use additional file like LinePad file. We can use openers, which are suggested but not included in the manufacturer's sequence. This is, once again, a little bit depending on you. Some dentists prefer to use 04 and prefer to use them in a traditional way. Some dentists use technique mixing 04 and 06. Sometimes some dentists prefer the 06 and also want to finish the apical size with bigger size, 30 and 35. But what I'm suggesting today is what I'm doing in my practice. I like to use them in this way, a simplified technique, because I like to do things simple. So this is the simplified technique with actually 2 files and 1 manual file. And you have to do the glide path up to a 15K file. And then you use the X7 1704, which is a very interesting file because it's more flexible than the stainless steel. So it will reach the apex with not a lot of stress. So you have to use them very gently with Mimerachi if you want, or with a very gently step-by-step approach. And after you reach the apex, what you have to do, you have to flare the canal. Because if you flare the canal, you make the life much easier and much more stressful for the 2504, which is the real shaping file. Actually, what we have here is we have a sort of a 1704 as a pre-enlarger, as a glide path file, sort of glide path file, and the 2504 as the shaping file. And in most of the cases, I'm really satisfied with the 2504 preparation. I can also, a little bit, if needed, enlarge by using more flaring. So actually, once again, is the rationally invasive concept that the final real shape of my, not really the apical third will be 04, but in the more coronal part, I can a little bit more flare the canal if needed. So by doing this, I mean, the technique is very simple, is minimally invasive, it's requiring less operative torque, it has a lot of efficiency and strength, and in some cases, you may add, for example, an opener. I'm using the Edge Taper Platinum SX because it's quite easier sometimes. But I think the techniques works very, very nicely also in complex cases, in medium cases. And if you want also, if you have the philosophy that you want to be minimally invasive in easy case, you only use this instrument to touch the canal wall and you are very delicate. But what I like more is that I can be very versatile. So the same sequence, if it's an easy case, I can use for with a bigger taper. I can have in my X7 portfolio increase the apical size. I can do a more rapid flaring with the edge taper S6 opener. I can use, if I want, also edge glide path files. I can do more or less coronal flaring, and also can do a very interesting thing. It's hybridization of motion. And most of the things are optional, but actually I try to keep things simple. So the great majority of my cases that you will see will be with only 2 files. But only with 2 files, if you brush, if you know the anatomy, you will have this very, very nice kind of 3-dimensional result with respecting the canal anatomy and very nice. So what I do in general practice, when I go in, I can use Mimerachi technique or a step-by-step technique, and this is my speed and my torque. I can play a little bit, but when I go out, what I do, I increase the speed and I reduce the torque. So this was the first instrument, and then I do the same when I'm using the 25, same speed, and when I'm going out, I'm using a higher speed. And this is very rational because when I'm going out, when I'm doing brushing, it means that the motion is much safer, and I could also increase the taper if I want. Once again, this is quite nice, and at the end, the results are very, very interesting for this kind of molar cases. Speaking about clinical use and motion, the other thing I want to tell you is that some people also like reciprocation. And for the people they like reciprocation, I have 2 suggestions for you. And suggestion number 1, you can use the X7 in this way. When you go out, you use X7 with a clockwise reciprocation, which is not the 30, 150, it's 150 and 30. Obviously, you have to find the motion, but nowadays there's a lot of motors on the market that allows this possibility. And you go reciprocating when you go in, so you are a little bit safer. And then when you're working out, you can use continuous rotation, because in this case, when you're working out, you're cutting more, and you need to have a more efficient technique. And also you also need to have a technique that removes better the debris, since you are making more debris. So this hybridizing motion with technique, I also like a lot with this 7, and it works fine as an alternative for the continuous rotation. So at the end, if I have to summarize, I have to say that what are my suggestions for using for the edge file X7 is that you have to modify the coronal curvature to reduce the bending stress by selective flaring. You have to reduce the torsional loads by progressing step by step and increase taper if needed. You don't have to hurry. You can leave the complex apical shaping at the end. And obviously, you have to modify the curvature according to the crown down principle. And for the apical part especially, but for the whole procedure, you can use the selective 04 martensitic flexible bendable resistant file that requires less torque, and they are more efficient. If you like, As an option, you can use reciprocation when you go in and continuous rotation when you go out. This is reciprocation. And obviously, if you are minimally or racially invasive, sometimes you may also use a minimally invasive, predictable, and easy obturation technique that I will show you soon. Or this is very interesting technique, the simplified technique. I'm always using the simplified technique, as I explained to you. 2 instrument, excellent strength and flexibility. And I'm very happy about this. So speaking about this, I asked at the very beginning why a new file system, and I wanted to prove if we have better performance safety. I think all the scientific data I showed to you will allow me to say yes. I was able to show you what I'm doing with using 2 files with a simplified technique. And I show you my idea of versatility in terms of taper and motion. So the way I create the taper and the way I'm using the motion, also with hybridization. And I show you the difference between minimally invasive and rationally invasive technique. And at the end, I'm quite proud, I'm very proud of the result I'm getting. Speaking about reciprocation, if you like the traditional reciprocation, the counterclockwise reciprocation, I'm just suggesting you quickly a very possibility with the Edge1 file, because we test a lot in article. And once again, due to their very specific and great heat treatment, they are more resistant to fatigue, they are more flexible, they are more resistant to torsional fatigue to any other competitors, and that results in very, very nice treatment. The last thing I want to, since we still have 1 minute, I want to show very, very briefly the fact that with this kind of files, we have all the accessory products. But speaking about minimally invasive and rationally invasive technique, we also can use very, very interesting, a new way of doing a root canal obturation by using bioceramics. And this is also obviously a paradigm shift, because before, gutta-percha was the core material and there was only a thin layer of sealer to fill the gaps between the root canal walls and the gutta-percha. Nowadays, we have a sealer that has become the core material, the most important materials. And this is because we have, an excellent material which is extremely biocompatible and extremely effective and can be the core of the obturation. So we have this kind of bioceramic sealers that are calcium silicate, calcium phosphate based materials that are designed specifically for root canal sealing. At the very beginning, they were only for cold techniques, but now we have the new products that are, for example, the BC Sealer High Flow that can also be used for warm techniques. And they are non-resorbable bioceramics, bioactive. They form a bond with dentin and stimulate a natural healing osteogenic response. And they're very, very easy to use because they are pre-mixed hydrogels that sets in the presence of moisture. But what is very interesting here is that it's not only their bond, not only their very good radiopacity, is that they have expansion during time of set, so they will fill the gap much better than any other material. They also have an excellent biocompatibility. They have a potent antibacterial effect, and therefore they can be used with cold and warm techniques. With cold techniques, it's extremely simple. You just put the sealer a little bit in the canal up to the middle part of the canal, inject it very easily with the syringe and the specific needle. Then you can take a gutta-percha cone and go a little bit in and out to do hydraulic pressure. And then when the sealer has reached, or you think has reached the apex, you fix the gutta-percha cone at, a little bit shorter than the working length, and the obturation is done. You only have to cut the cone at the orifice. And obviously you can use with this kind of sealer any gutta-percha cones, but there are also specific gutta-percha cones with a cover with bioceramic. And the main difference here is that the gutta-percha cone is not the core materials, but only as a carrier for the sealer in the cold technique. And the gutta-percha cone acts as a path for the retreatment. So we put a gutta-percha cone inside the canal because the sealer will be a little bit too difficult to remove because it adheres very nicely to the canal walls and is very strong. So by using a gutta-percha cone and leaving a gutta-percha cone in the center, that will help retreatment if needed. So technique is so simple, and you just inject the sealer up to the middle part of the canal. Then here is the sealer coming, and this sealer is extremely flowable, and it sets in humidity, so it's not there's no interference with the moisture in the dentinal tubule. Actually, it needs the moisture, so you move the cone a little bit in and out, and due to its flowability, the sealer fills all the gap and the irregularities, and the obturation is done. At this point, the cone is, you can fix the cone inside the canal, you can take a radiograph, and if it's okay, you just cut the cone and remove. If it's not okay, if it's maybe short, you can add a little bit of sealer and move a little bit more of it and fill it. If it's long, you can remove it. So it's very, very easy. But with the new, with the new material, you can also use the traditional technique, the System B technique, and the worm techniques, and it works very, very nice. Indeed. So having said this, this is my final slide, and I think if you follow all this concept, this three-dimensional approach, you will have excellent results, which are obviously achieved by a combination of many things: your knowledge, the use of the proper instrument, the use of the proper instrument with the proper technique, the use of the instrument which are rational. And in this case, you can be at the top of the edge in our, in our field by getting the most from the instrument we have nowadays. And the one I show today, I think, are, probably the one that give us the best feature available at the moment. And so I wish you to treat a lot of nice cases very nicely with this kind of instrument. So I'm done with the presentation, and I'm ready for your question and answer. Thank you for attending.
Professor Gambarini, thank you so much for that great information. We've got a couple questions here for you. The first one was referring to the X7. Would you be able to explain a little more the settings of the handpiece?
Okay, speaking about the torque and the speed, actually we have the brochure from the company that gives you the setting of the files. And what is suggesting here is to use them with the traditional setting, maybe 350, 400, and then torque about 2 newtons. This is the normal one. But they work nicely with any other setting. And the reason why they do this is because of their properties. So if you increase the speed, you make them a little bit more effective in cutting. But you don't need to increase the torque in this case because they still are low torque instrument. And in the same way, if you increase the torque, that doesn't make a lot of difference because they already work very nicely with a low torque.
Great. And then what irrigation protocol do you find best for disinfection of the X7?
Disinfecting the instruments or disinfecting the canals? Because disinfecting the canals, what I'm suggesting when I was speaking about Mimerachi and I was going step by step, I irrigate quite a lot during instrumentation. But also the Mimerachi technique I explained to you is a less producing debris technique. So what is very important in endodontics is to clean the canal. But we have to understand that, cleaning the canal, people always speak about cleaning the canal, but they don't speak too much about producing debris. There are some instruments, especially the one who have bigger tapers and bigger, longer working part, that if you don't use in a step, in a very small step, but if you keep on going in and in, you create a lot of debris, much more debris that the flutes of the instrument can remove. So my suggestion here is if starting from the instrumentation, if you want to improve your irrigation, first try to improve making less debris. So you can do this by irrigate more frequently. When you go in step, you can irrigate more frequently. You can use a file like X7 that has a shorter working part that it will definitely produce more debris. And if you want to produce debris and flare, it's more intelligent to create and to produce debris while you're working out, because in this case the debris will be floating, and they will be much more easily to be removed by the instrument itself, but also by the irrigation. So there's not a lot of study about this, but it's quite interesting thing. So my first thing is try to make a technique and an instrument that produce less debris. Secondly, after instrumentation is over, you may have a technique that improves cleaning. And in this case, I use a 3-step technique: sodium hypochlorite, ADTA, sodium hypochlorite. So three phases, and I'm using sonic or ultrasonic, but any other activation is fine. So this is my protocol. About the instrument itself, actually, there is no, they came from a sterile package, so you don't have to sterilize at the beginning. So if you're using them single use, there's no issue. If you want to reuse them, actually, we tested that the normal disinfectant does not affect any properties of the instrument, including the one coming from the heat treatment.
Great, thank you. Let's see. Can you use the apex locator with X7 files?
Yes, of course. This is normal NiTi. The only thing is thermally treated NiTi, but the material is NiTi. So if any NiTi works with the apex locator, which is, already well established, they will work nicely with X7. Actually, I'm using this cordless motor with integrated apex locator.
Right. And then you touched on it at the end briefly, but why do you increase the speed and reduce the torque when preparing the canal?
Well, when I'm getting out, I do this because it makes flaring, or it makes cleaning by touching all the canal walls faster and more efficient. I don't increase the speed when I'm getting in.
Got it. And then we've got time for one more question. What makes the X7 flexible, and what sizes and lengths do you prefer?
Well, what makes it flexible is, apart from the design and apart from the fact that the working length, the minimum fluid diameter, so the dimensions, let's put it this way, but the real trick is the heat treatment, the proprietary heat treatment, the firewire heat treatment. That makes a huge difference. I explain, and I will tell you once again, if you play a little bit with the design, you can increase flexibility 5, 10, 15%. With the X7, with the heat treatment, we can improve flexibility of the NiTi 2 times, 3 times, which is 200, 250%. that's huge.
Got it. All right. Well, with that, we are out of time and out of questions. So I would like to thank you, Professor Gambarini, for your time and presentation today. And thanks to everyone for attending and viewing with us today. Everyone in attendance will receive a link to view the recording in the coming week via email. On behalf of Henry Schein, thank you all again for attending, and I hope you have a great rest of your day.
Thanks a lot. Bye-bye.